In today's lesson, we are going to be looking at some composite shapes. And before we get into our composite shapes, we want to look at some unit conversions because we may have to convert between units when finding area and perimeter and volume of different shapes. So we have our useful conversion facts over here, and we're given a bunch of measurements and we just want to convert them where possible. So 350 centimeters equals 3.5 meters, right? We're going to divide by 100 centimeters because it's 100 centimeters in a meter. 12.08 meters to centimeters. So again, going the other way. So instead of dividing by 100, I'm going to multiply by 100 and get 1,208. 18 centimeters or inches to centimeters. I'm going to multiply by 2.54. And I end up with 45.7 centimeters. Centimeters to inches, I'm dividing by 2.54, and I get 49.2 inches. 6 3/4 feet, or 6 3/4 of a foot, converted to inches. So I know that there are 12 inches in a foot based off of my chart. So 6.75 times 12 gives me 81. F, feet to inches to centimeters. So again, multiplying by 12, we get 42. And then taking that, multiplying it by 2.54, 106.7 centimeters. 2 1/4 yards, or 2.25, is 6.75 feet. So we're multiplying that by 3. Then we're multiplying this by 12. To get 81 inches, multiplying it by 2.54 to get 205.7 centimeters, and dividing that by 100 to get 2.05 meters. 7.6 is 760 meters, which is 299.2 inches, which is 24.9 feet, which is 8.3 yards. Right. So again, hopefully you're able to convert between the different units. And to try that, we have a room that is measuring 8 meters by 12 meters by 2.5 meters, and we want to find the volume in cubic yards. So we need to go through and convert all of these measurements to yards, so that when we find the volume, length times width times height, we can find it in cubic yards. So go through, we know right now 8, we'll say 8, 2.5, and 12. Really, it doesn't matter too much for this table, but we'll keep it somewhat realistic. Our room is 8 meters long, it is 2.5 meters wide, and it is 12 meters tall. Actually, or we can say it's 12 meters by 2.5. That might be a little bit more realistic. 2.5 meters tall. So go through, convert between the different units, and then find what the final volume is in each unit, or each cubic unit. So this is just going to practice a little bit of what we did. Use the chart from above. I'd recommend pausing the video and you can come back and we'll see what our final answers should be. So coming back, this is what our chart should look like. We can see the final volumes in each of the different units, and you can see that it's not quite the same as using the conversions above to convert between the different units. And that is due to the fact because volume is a cubic unit, because it's 3 measurements multiplied together. All the conversions that we had above, that is more for singular units, or just kind of one dimension, whereas cubic is 3 dimensions and volume is 3 dimensions. So we want to be a little bit careful about just converting straight from say meters squared and then saying, oh well, there's 100 centimeters in a meter, and then convert that to inches and so on, right? Because not meters squared, meters cubed. when we're dealing with volume and area, the conversions are different. So you have to convert it at the very basic level, which we did in the first 3 rows, and then calculate the volume. So some things that you might have to do now. So determine the size of a ventilation fan, normally rated in cubic feet per minute, or CFMs, that will be needed to change or needed to give 5 changes per hour in the room. Right, so basically we have a ventilation fan and we want to be able to replace all the air in the room 5 times every hour. Right? And we want to figure out what size of a ventilator or ventilation fan would we need in terms of CFMs. So we do have our measurement because it is in cubic feet. That's what our CFM means, cubic feet per minute. So we do need to use our measurement that was in cubic feet. So 8,970 or 8,497 cubic feet, or feet cubed, is our room. So we'll just quickly draw our room. So our room has a volume of that. And we need 5 changes per hour, every hour. So to figure out how big the fan would be, we need to take our volume, multiply it by how many changes we need. So multiply it by 5, which will give us 42,485 feet or cubic feet per hour. So essentially, that is how much volume needs to be cycled every hour. So then to figure out how much cubic feet per minute, we're going to take that number, the 42,485 feet per hour, and we're going to divide it by 60, because that's our time, our 60 minutes. There's 60 minutes in an hour. So basically it's saying 42,485 cubic feet per 60 minutes. And to find out then the rate per minute, I just divide the two and I get 708 CFMs, but the question wants us to round up to the nearest 100. So that would be 800. And the reason we're rounding up is because you think of fans, they're kind of just designed to ventilate a certain amount. It's not very specific, like the 708. You wouldn't find a fan that can do 708, but you would be able to maybe find one that's 700 or 800. So that's the reason why we're rounding up to 800, because based on fan size, right? There's only certain size fans that are produced. There's not a fan for every individual CFM. So therefore, the size is 800 CFMs. And again, 800 would be enough to clear out everything 5 times an hour. So try to go through the same thing for the second one, right? Reading the question, now we have a large rental room at the Pelham Community Center, which is approximately double that volume, right? So I can at least start off with that information, double the volume. So I'm going to multiply or double our volume and get 16,994. It does tell us that there is 1 change per hour, or not per hour, per every 6 minutes. So that means if there's a change every hour or every 60 minutes, there would be 10. So there'd be 10 changes every 60 minutes, right? So 1 change per 6 minutes is 10 changes every 60 minutes. And now I'm going to go through the same step. I know how many changes there are per hour. So I'm going to take my volume of the room, multiply it by 10, and get 169,940 cubic feet per hour. Essentially, that's how many cubic feet there are going to be. And I'm going to take that amount, 169,940, divide it by the 60 minutes in an hour, and that gives me a cubic feet per minute of 2,832 CFMs. So that means this fan has to clear 2,832 cubic feet per minute to match these standards or protocols. Again, we're going to round up to the nearest 100 because of how the fans are built. So basically, we need a fan that's rated at 2,900 CFM. Therefore, you need 2,900 CFM, or need a 2,900 CFM fan. So this is all just about basically seeing how much total volume is going to be pushed out every hour, and then dividing by 60 minutes to figure out the CFM, or the volume per minute, you could say. So other situations we're going to be looking at are composite area. So each diagram below is the footprint for the ground floor of a custom built house. For house insurance, you need to know the area or square footage. And for an upcoming renovation, you need to know the perimeter. So we want to calculate the perimeter and area of each footprint. So this one, we're going to go work through the basics, and then I'll let you work on some of it on your own, because we do have basically the basic formula. So there's nothing too complicated in terms of the formula. It's more about what you need to do from there. So when we have these shapes, so these shapes are obviously a little bit different from our normal shapes. And our normal shapes would be like our circles, our squares, our rectangles, parallelograms, trapezoids, those basic shapes. This is obviously not a basic shape, but what we can see is hopefully some of those basic shapes here. So here we see, if I were to draw a dotted line right down here, we can see that we have a large rectangle with a triangle. Let me keep it. We have a large rectangle with a triangle cut out. And we have a semicircle. So I can find the area of a rectangle, and I can also find the area of a semicircle, and I can find the area of a triangle and remove it to find the total area. For the perimeter, we see some measurements, right? We see the dimensions of this triangle here are 10 by 10. So we can figure out this hypotenuse. I do know this far side is 30 based off of the measurements on the bottom, 20 plus 10. I can figure out this measurement as well. Oops. This measurement as well, because it is a semicircle. And I can figure out that measurement as well because it is a triangle, a right triangle specifically. So let's go through, and we'll actually just work through this one, and then we'll do the second one on our own. So we need to find some information first. So I need to figure out this semicircle for the perimeter, and I need to figure this diagonal for for the perimeter. So let's start with the semicircle. So perimeter of a circle is pi r squared. So A is going to equal 2 pi, or not pi r squared, 2 pi r. So 2 pi r, and we're going to divide it by 2 because we have a semicircle. So A is equal to 2 times pi, or 3.14, times r, which is our radius. And our radius in this case is half of our diameter. So using the information that's already given to us, if this entire distance here is 32, this portion is 10, that means this segment has to be 22. And if I just want half of it then would be 11. So that means the radius for my triangle, or my semicircle, is 11. So 2 times pi times 11 divided by 2 gives us 34.54, and we'll use the little feet symbol. So that means A is 35 or 34.54. We now have that to help us find the perimeter. We just need C, our diagonal. So this is going to be similar to Pythagorean theorem or sum of squares. C squared equals A squared plus B squared. C squared equals 10 squared plus 10 squared. C squared equals 200. And C equals the square root of 200, which is equal to 14.14. So now I know this diagonal. So that helps me to figure out my perimeter. That's the first one we're going to start with. That's the easiest one, distance around. So I'm just going to start on one side, 32 plus 30 plus 34.54 plus 14.14 plus 20 equals 130.68 feet. So that's all that little apostrophe means. So I know the perimeter now. Now let's work through the area. The area is going to be a little bit different because we have multiple shapes. So I'm going to find the area of my rectangle, which is length times width, the area of my semicircle, which is pi r squared. But because it's a semicircle, I'm going to divide it by 2. And I'm also going to find the area of that triangle because I need to subtract it from this overall rectangle, which is base times height divided by 2. I should have enough information to go through and solve. So for my rectangle, length times width, 30 times 32 is equal to 960. Pi times the radius, which we know is 11 squared, divided by 2, gives us 189.97. And for the triangle, 10 times 10 divided by 2, which is 50. Now, to find my total area, I can do 960 plus 189.97 plus 50, or sorry, not plus 50, minus 50, right? Because that triangle is not included, but we did over-exaggerate our shape to imagine we had a square or rectangle there. So I need to subtract that part that's missing. And in the end, we get 1,099.97. And the units, so the little apostrophe meant feet. So this is feet squared. So that means the total area of this floor plan is 1,099.97 square feet with a perimeter of 130.68 feet. So all we're doing is just breaking up into the simpler shapes or the basic shapes that we do know the area formulas and perimeter formulas for. And then we're going through and calculating the individual shapes and adding or subtracting them. So floor plan B, made up of some triangles, some parallelograms. We want to find all the dimensions, right, so that we can go through and find the area and perimeter, as well as find the length of side A or X and the value of theta. What angle are each of these triangles at? So I'm going to walk through the first part. I'll help you find X and theta, and then I want you to go through and calculate the perimeter and area of this shape. So I'm going to just draw my triangle really briefly, the one that we want. 4 meters, 4.5 meters. It is going to be a right triangle. We're looking for theta and X. So theta, we're going to have to use our trig. Right, so we're going to have to use, based off of theta, we know our opposite and our hypotenuse, right? OH and A. So we're using sine theta equals opposite or 4 over 4.5. Theta is going to equal sine or inverse of sine 4 over 4.5. And we get an angle of 62.7 degrees. For our missing side, we are going to use Pythagorean theorem or Pythagorean formula. So it's usually a squared plus b squared equals c squared. The two legs added squared and added together equal the hypotenuse squared. But because we're finding the hypotenuse squared, we're going to subtract actually our one leg from the hypotenuse. So x squared is going to equal 4.5 squared minus 4 squared. X squared equals 4.25. X equals the square root of 4.25. X equals 2.06. So now I know X is 2.06. And if I look at this shape, there are a lot of dashed lines on the sides, which helps us find other information. Right? So rather than labeling every side here 4.5, 4.5, 4.5, we can tell that in these triangles, these sides are all the same. Same thing with the solid double dashes. These are saying that these heights are 4. These thinner dashes, so this is 10, so that means this is 10. We see 4.5 on the other side here. And because we have triangles that are all the same going up, we know then that at the bottom, this base is 2.06, 2.06. So use this information to go through and find the perimeter of this shape as well as the area. Right? And you can always refer back to the last page. At the top, we have all of the useful formulas for area. Some of the ones we don't probably know off the top of our head is the area of a parallelogram and the area of a trapezoid. So I'd suggest pausing the video, try to go through and solve this, find the area and perimeter of this shape, and we'll come back with our answers. So coming back to this question, the perimeter should be relatively straightforward. We do have all the information for all of the sides, so we can go through and add them up individually. I just did 5 times 4.5 because we have 5 of the same measurements, plus the 5.5 up at the top, plus 10, plus 2.06, and got 40.06 meters. So again, the perimeter should be relatively straightforward, provided we don't have to find any sides. And if we do, chances are it's either for a circle or a triangle. For the area, we had to find the area of two kind of different shapes that we hadn't quite seen before, which in this case would be our parallelogram and our trapezoid. So in the bottom, we can see the bottom shape here. Let's color these ones in quickly. Our bottom shape here, there's our parallelogram. We also then have our trapezoid. And then finally, we have a triangle. So we have 3 shapes, 2 we probably haven't seen before. So the parallelogram, the bottom one is base times height. So the base is the 12.6, the entire distance along the bottom, and our height, which is 4. For our trapezoid, A plus B times H. A is the top side. B is the bottom side, so we add those two sides together. We multiply by the height, which is 4, and then we divide by 2. That's part of the formula. And then finally for our triangle, base times height divided by 2. And in the end, we should get a total area of 104.6 meters squared. So again, the concepts in this lesson should be relatively straightforward. Finding the area and perimeter is something you've done probably starting in elementary school and all the way through. Difference one is finding composite shapes. So we're trying to find out or break up our unique shape into these more common shapes. The basic ones that we know that we have the formulas to. We see all of these ones here. As well as then using the volume to find the size of a ventilation or a ventilation fan. Right? So just basically figuring out how much volume needs to be pushed out every hour and then dividing that by 60 because there's 60 minutes every hour and we get our size of the ventilation fan. So again, hopefully a relatively straightforward lesson. Please make sure you are practicing or just touching up on some of the basics if this was a little bit confusing, right? Go back. You can always go find resources on finding area and perimeter. But chances are with the formula, you should be relatively set up.